there are two different ways we're going to divide polynomials. We are starting with long division. So we are going to back up to elementary school real quick. Don't get ahead of me. Hopefully we can all divide correctly, but I want to talk about the steps because they are literally the same. If I have 5,467 divided by 13, I'm going to put 5,467 inside the little house, right? 13 goes out here. We all agree with that? This divided by this. Okay, so then I only have one term out here, and 13 clearly doesn't go into 5, so I have to use 54, right? So 13 into 54, I'm thinking 5 is too many. You think 4 would work? Yes? We'll try 4. Okay, and I put it above the 4. I don't put it above the 5. Your placement matters, okay, because we're dividing into 54. So 4 times 13 is 52, right? Then what do you do with those two numbers? Subtract. Every time. Subtract. So when I subtract, I get 2. And then I bring down the 6, which becomes 26. 13 goes into 26 2 times. 2 times 13 is 26. Once again, I subtract. And this zeroes out, and I bring down my 7. How many times does 13 go into 7? None. 0. So I literally put a 0 here, right? So I end up with 420, and I have a remainder of 7. Now, when you very first learn it, I'm pretty sure you put like 420 and then R7 because you don't know what to do with it yet, but we're way past that. So if I don't want to put R7, I put 7 over what? 13, because it's 7/13 that's left. 7 over 13. That is my answer. Does that make sense? If you can do that, you can do the rest of this. Now, there's something that we don't put here that we just kind of know what's happening. If I know I have this 420, if I knew what 7/13 was as a decimal, what would I do with those two numbers to get the whole thing? I have 420 and I have whatever that decimal is. What do I do with them? Do I multiply them? I add them, right? So if I have like 1.5, it's 1 plus a half, right? We just don't put the plus there, and we just kind of know that's how it works with fractions, right? We're going to have to actually add it when we have remainders on the polynomials, right? But this is my answer. Any questions at all? Okay, good deal. So this should totally be a review. I think maybe you first learned this now in Algebra 1, but I know for sure it's in Algebra 2. I don't know. They changed things so much. So, but I will teach it to you like it's brand new to you for those of you that are photo math people. All right. So what I never leave myself enough room above that. So I'm saying just like drop down a little bit, but go ahead and write what goes underneath. So I've got 3x cubed plus 2x squared minus 37x plus 12. So all that is underneath, and I have x plus 4 on the outside. So now I have 2 terms, right, on the outside. I only had 1 here that I had to worry about. I have 2 terms here. But when I try and figure out what's going to go on top, I only pay attention to the first one. So I take this x, and I want to know how many times does x go into 3x cubed. So basically, what I ask myself is if I take 3x cubed and divide by x, what am I left with? Yeah, 3x cubed divided by x leaves me with what? 3x squared. And so since it's 3x squared, I'd put it above my x squared term. That matters. This is 3x squared. Then just like after I got my 4 over here and I multiplied 4 times 13, I'm going to multiply 3x squared by both of these. So 3x squared times x is 3x cubed. 3x squared times 4 is a positive 12x squared. And I line those up with the ones that match. Over here, after we got our 52, we subtracted it from 54, right? So we need to subtract this as well, and I'm subtracting the whole thing. That is the only time I'm going to write the parentheses and the negative out there. Because basically when you multiply through by that negative, then all you're really doing is changing the signs on each term. Okay, so just go through and change the signs. Don't forget to do that. That's one of the most common mistakes here. So then when I do that, these zero out, and this gives me negative 10x squared, and I bring down the negative 37x. Then I take 10x squared, and I divide it by x. I'm sorry, negative 10x squared. that leaves me with negative 10x. So when I multiply, I get negative 10x squared minus 40x. Then I change the signs, positive, positive, because that's what happens when I subtract. These zero out, and I'm left with 3x, and I bring down my 12. 3x divided by x gives me 3. So I get 3x plus 12. I change the signs, and those zero out, and so do those. My remainder is 0. So my answer then is 3x squared minus 10x plus 3. Right here? Because when I multiplied, I had 3x squared times x is 3x cubed, and then 3x squared times 4 is 12x squared. 12x squared. So just like here when I had to multiply 4 times 13, I have to multiply this 3x squared by both of these terms. Okay, so then when I got my negative 10x, I multiplied and got that. I'm sorry, I got it right there. And then negative 10x times 4 is negative 40x right there. Does that make sense? Okay, good question. What else you got? All right, awesome. Then you do number 5 on your own. See what you can do with number 5. So this is the right idea, but it doesn't leave you with x. It leaves you with what? X cubed divided by x is x squared. All right, so I'm going to talk you through it. So 2x goes into 2x cubed, x squared times. So x squared goes above my x squared term. Okay, you've got to keep your work organized. So then I get 2x cubed plus 7x squared. I change the signs on both. Those zero out. Negative 2x squared, bring down my negative 19. 2x goes into negative 2x squared, a negative x times. So then negative 2x squared minus 7x. Don't forget to change my signs. Then those zero out. Negative 12x minus 42 once I bring this down. Okay. Then 2x into 12, negative 12x is a negative 6. And negative 6, this will give me negative 12x minus 42. I change the signs. Those both zero out. And I am left with x squared minus x minus 6. Okay? What questions do we have? Anything? Okay. So we're going to work through number 6 together because we got to talk about some placement so that you don't start making up math, which is always a bad thing. So let's go ahead and I'm going to write this out. So x to the fourth plus 3x cubed plus 4x squared plus 24x minus 32. That's all divided by x squared plus 8. All right, so just like before, x squared, I divide that into x to the fourth. What does that leave me with? X squared, and it has to go above my x squared term. All right, so then I get x to the fourth, and then x squared times 8 is 8x squared. I put that underneath my x squared term, and there's a big space there, which is totally fine, but you've got to line stuff up correctly. So then I go and change my signs. These zero out. This just drops straight down, 3x cubed. 4x squared minus 8x squared is negative 4x squared, and then I still bring down my positive 24x. Everybody with me so far? Gotta line them up. So x squared divides into 3x cubed, and I get 3x, so that goes above my 3x term. Oh, got my colors all backwards here. This goes, sorry, lost track because I messed up all my colors. Not that it matters, but plus 3, right? All right, so 3x squared, oh, 3x, dang it. So this gives me 3x cubed, and then that's a 24x, so 24x goes right there. I go in there and I change my signs. Then these zero out, and these zero out. But this comes straight down. I get negative 4x squared, and I bring down my negative 32. If you don't keep your stuff organized and you can't read your own handwriting, that's going to be a problem. Then x squared into negative 4x squared is just a negative 4. So we get negative 4x squared and a negative 32. I change the signs, and they all zero out. And my answer is x squared plus 3x minus 4. What questions do you have? Line them up. All right. Okay, so these all had remainders of 0. That's not always going to happen. So let's work one where that's not going to happen. That is number 7. So underneath, I'm going to have 3x cubed plus 7x squared plus 2x plus 3. On the outside of that, I have x plus 1. So we're going to work it exact same way, because you don't know at the beginning that you're not going to have whether or not you have a remainder. X goes into 3x cubed, 3x squared times. So this gives me 3x cubed plus 3x squared. Then I change my signs. Negative, negative. Right. Then those zero out, and I get 4x squared plus 2x. X into 4x squared is a positive 4x. So I get 4x squared plus 4x. Change my signs. Cancel those out, or those zero out rather, and I get negative 2x plus 3. Bring my 3 down. X goes into negative 2x a negative 2 times. So I get negative 2x minus 2. I change my signs, and I end up with 5. Okay? So I have a remainder of 5. I don't put R5 out there. Instead, my answer is the polynomial at the top, so 3x squared plus 4x minus 2. Then I add the remainder, that's plus 5 over what? X plus 1. Over whatever your divisor was. And that's it. And our remainders are important and are going to help us when we're graphing stuff, by the way. Yes, ma'am? Very good question. If the remainder was negative, it would be minus 5, and the answer is no. Just like with just a normal fraction, you always add the remainder, right? So this would be plus a negative 5. And yeah, okay, value-wise, it would be the same. But if your numerator has more than one term and you don't use that negative correctly, it's going to be a hot mess. So always add it, and then whatever these signs happen to be, you just plop that in the numerator, and you're good to go. Okay? Good question. What else you got? Yes, we will. We'll come up with one. All right, but you go ahead and do number 8 on your own. What is that there? Okay, you making stuff up?
No, I was going to raise it.
Oh, okay. I'm just making sure. You caught yourself, so that's good. Once you're done, check yourself with me. Ask me questions if you need to. If you didn't get that, see if you can find where things went weird. Hopefully it was just a little brain fart and not a complete lack of understanding. Any questions at all? All right, can I move on? All right, so we're going to work through number 9 together. Number 9, we're dividing by a trinomial, which really doesn't change the whole process, but we're still just going to do it together for sake of having done one. So underneath, I'm going to have x to the 4th minus 5x cubed plus x squared plus 20x minus 10. On the outside, I have x squared minus x minus 5. So x squared goes into x to the 4th. X squared times, I put that where? Above the x squared. So this is my x squared here. So then I get x to the 4th minus x cubed minus 5x squared. I changed my signs. Don't forget to do that every single time. These zero out, and I get negative 4x cubed plus 6x squared plus 20x. X squared goes into negative 4x cubed, a negative 4x times. So we get negative 4x cubed plus 4x squared plus 20x. Change my signs. These zero out. I get 2x squared. These zero out, and I got to bring down my negative 10. So 2x squared, or x squared goes into 2x squared a positive 2 times. So I get 2x squared minus 2x minus 10. Then I go and change my signs just like I do every single time. These zero out. This just comes down as a 2x, and these zero out. So my remainder is just 2x. My answer then is x squared minus 4x plus 2 plus 2x over x squared minus x minus 5. Can I cancel those x's out? No. Can I cancel these 2's out? No. Don't be making up math. That's it. You're done. What questions do you have? We good? All right, so let's look. We got one more kind of special case going on here. If I have a missing power, okay, if you have a missing power in the dividend, that's what's inside the house, you have to put a placeholder. So if you look here, I've got x to the 4th minus 64x squared. So there's no x cubed in there. There has to be an x cubed term in your dividend. If what you're dividing by, it doesn't matter, because if you look over here on this one that we did, we divided by x squared plus 8. It was missing an x term. Totally fine if it's missing on the outside. Can't be missing on the inside. All right? So to put my placeholder here, once I start writing what goes underneath, I've got x to the 4th. Since there is no x cubed term, I put plus 0x cubed. Then minus 64x squared plus 9x minus 80. So if it's a 4th degree, there should be 5 terms. If it's a 6th degree, there should be 7 terms. 3rd degree should be 4th. You'll always have one more term than whatever the degree is. So even if you're missing your constant, you'd have to put a plus 0 out there. Then we divide by x minus 8, and the rest of the process is exactly the same. All right, we're going to take x into x to the 4th. That is x cubed. I put it underneath my little placeholder term. So that gives me x to the 4th minus 8x cubed. Change my signs. Those zero out. And I get 8x cubed here. Bring down my negative 64x squared. 8 goes into 8x cubed. A positive 8x squared times. So 8x cubed minus 64x squared. So I change my signs. These zero out, and so do these. So I bring down my 9x, but I also now have to bring down my minus 80. X goes into 9x 9 times. Where do I put it? Over the 80. So basically I have a 0x term here, which is totally fine. So then I get 9x minus 72. Change my signs, and I get a negative 8 right here. So line them up. Whether it's underneath or above, you line them up, because you should always finish. There might be some zeros in there, but always finish. And then what I have up here is x cubed plus 8x squared plus 9. Okay, I don't leave a big space there. That wouldn't make any sense. My remainder is negative. That doesn't matter. I still put plus. Then my numerator is negative 8 over x minus 8. Can I cancel out those 8's? No, good God, no. And that is it. I'm done. Okay. What questions do you have? All right, you do the last one on your own. I'll put the answer up there in just a second. When you finish it and you double check yourself, if you agree and you don't have any questions, you can go ahead and get started on your Delta Math. I will work through it too, so you can see it if you need to. And when you're doing your Delta Math, you need paper. You can't just stare at it and do it in your head. All right. There it is worked out if you needed to find if you didn't agree. But once you check yourself, go ahead and get started. If you have any questions, let me know.